Good day everyone, I am Takalan Francesca Dayan. So in this video, I am going to discuss about the evaporated water, rainfalls, ocean currents, and thermohaline circulation. So first, we have evaporated water. It's water that changes from liquid to gas or water vapor by absorbing heat energy about 580 calories per gram, which is stored as latent heat. When the water vaporizes and cools, it changes back into liquid through evaporation. During this process, water absorbs a large amount of energy, about 580 calories per gram. This energy is stored in the water vapor as latent heat. Examples: in the Philippines, warm ocean water evaporates and water fuels typhoons, making them stronger. After rain, puddles disappear because of evaporation caused by heat from the sun. Rain forms when two conditions are present. We have the moisture source, and the second one is lifting mechanisms. As warm, most air rises, it cools at higher altitudes. The water vapor then condenses into tiny droplets, forming clouds. When these droplets become heavy, they fall as rain. So, there are three main ways air rises. So first, we have the orographic lifting. Air is forced up in mountains. Then the second one is the frontal lifting. So warm and cold air masses meet. The third one is the convection. So convection is warm air rises due to heat from the ground. So next we have the ocean currents. The continuous movement of ocean water caused by wind, temperature differences, and salinity or saltiness, which help distribute heat and affect climate. Ocean currents are large movements of water in the ocean that affect climate. Surface currents are driven by wind. Deep currents are caused by differences in temperature and salinity or salt content. These movements help distribute heat from warm regions to cooler regions of the earth. So, a special system called thermohaline circulation. So, thermohaline circulation is a surface and deep water circulation system where both temperature and salt concentrations control the density of water, and contrast in density drive its movement. So, thermohaline circulation moves water based on density differences. Examples: the Alaska current keeps coastal areas cool and foggy during summer. So, that's the thermohaline circulation. Evaporation, rain formation, and ocean currents are all connected. Heat from the sun drives evaporation, which leads to the cloud formation and rain. At the same time, ocean currents distribute heat around the earth, helping control climate and weather patterns.
Good day everyone, I am Tablo and today I am presenting and discussing my report, and my topic is all about ice lost. So, climatologists warn that summer sea ice in the Arctic Ocean has thinned and declined in extent by about half. So the Arctic sea ice has become thinner and much smaller in area. And this means that compared to the past, there is only about half as much ice left, and this is due to climate change. Next, late summer Arctic ice may be gone entirely by 2030 or soon. Melting ice has a strong positive feedback effect. So scientists think that Arctic ice during summer could completely disappear by 2030 or even earlier. Positive feedback means a cycle where ice melts, temperature increases. Temperature increases, more ice melts. This cycle makes warming happen faster and worse. Next, as ice melts, exposed water absorbs energy and warms. So when ice melts, exposed ocean water absorbs more heat from the sun than ice. So the ocean becomes warmer, and this leads to more overall warming. Warm water retains its heat long into the fall, during the new ice that forms over winter. So warm water keeps its heat longer, even into the fall season. Because of this, less ice forms during winter. Next, uh, thinner, less extensive ice melts rapidly in spring, allowing greater warming the following summer, further enhancing heat absorption. So thinner ice is weaker, so it melts more quickly during spring, and this causes even hotter temperature in the next summer, continuing the cycle. Next, a warming. Ice-free Arctic Ocean contributes to warming worldwide. So, a warmer, ice-free Arctic contributes to global warming. It also warms nearby land areas like Siberia and Canada. Melting frozen ground, permafrost releases gases like carbon dioxide, CO2, and methane, CH4. And these gases trap heat and make climate change worse. For continuation, an ice-free Arctic also influences ocean circulation, allowing fresh, low-density water to interrupt thermohaline circulation. So, ice loss change how ocean water moves. Fresh water from melting ice can disrupt thermohaline circulation, or thermohaline circulation, the global movement of ocean currents. This can affect weather and climate around the world. Also, ecosystem is affected. Many Arctic animals depend on ice to survive, such as polar bears, seals, other marine animals. Also, this leads to ecosystem imbalance and possible loss of species. In conclusion, ice loss in the Arctic is not just a local problem, it is a global issue. It increases global warming, disrupts ocean system, and harm ecosystem. That's all, and thank you.